Thank you for being here. The idea of this session really started when I was talking with lots of people about how serverless is good because you don't need to think about servers when you do the deployment, when you need to do the scaling. But I started to think, what are the advantages on the other side, on the development side, when you start to use technologies such as AWS Lambda? Just a couple of words about myself. So I joined AWS 5 years ago. It will be 5 years in June. And one of the first things that I wrote was a shared file system running on top of S3. And I put it on GitHub. It's still there. There's people working on it. Then, when Lambda was out, I created this framework to manage the authentication of users from, for example, from a JavaScript web page, so to manage all the life cycle of users. It's interesting that both these two projects are now almost obsolete because now we have the Elastic file system that is much better than my product, and there's Cognito user pool that is much better than Lambda out, but they're still there, and there's people using the open source code. And this gave me a little bit of visibility, so I was contacted by Manning, and they asked me to write a book. And just to give you an idea, when I started writing this book, I had to insist to use the word serverless in the subtitle, because they say, this serverless thing, it will never start to get interest of the people. And now, actually, probably serverless is one of the most hot topics that you find in conferences. And I brought one copy of the book. So normally, I give the copy to the most interesting question. I was scared because there's a lot of people, but then we saw very few questions. So let's at the end, the most interesting question and question about time will not be accepted. And more recently, by the way, this is a discount code. So if you want to buy it, don't buy it full price. There is this discount code. It's always valid. It's 39, like the discount and my family name. Last time I was asking, but what happens if I put 69 instead of 39? So I didn't try. I hope they have a more robust check at Manning. And more recently, I was asked to create this free ebook. So this is an ebook that is completely free. You can download it. And the idea is to give the tools to someone that is new to serverless, to understand how serverless works, how can you use serverless in an agile context, what are the technology that you need to understand, such as how web APIs work, the REST model. These kind of free books that are provided by Manning are built selecting a collection of chapters from other books. So you get 5 chapters for free, taken from different books from Manning, but it tells a nice story. So if you want, you can just download it. So this is the only slide that I have on products. It's AWS Lambda. This is for the few people that were scared to raise their hands before when Goiko asked, who doesn't know what Lambda is? So with Lambda, you can upload your code. You can group your code in functions. And then you don't need to manage servers. We manage the scaling for you, and you pay by the hundreds of milliseconds of execution time and the number of requests. And there is a huge free tier. So I've seen startups creating an application with thousands of users, sometimes even tens of thousands of users, and still be in the free tier with Lambda. So quite an interesting perspective. And with Lambda, you can create this function. When you create a function, this function can be invoked using the AWS API or triggered by some event. You can plug a trigger, and the function will be executed. Normally, at this point, I create a function, but since almost everybody here seems to be quite an expert, I'm not doing that live. But there is this repository that I have on GitHub. There's a few examples of how to build first functions, and I can show you just a little bit how that works. So this is greetings on demand. It's the first function that I usually show. It's a sort of hello world where you can pass a name. So you see, this is the Node.js syntax. It's almost the same in every language. You can create a function. You get an event in input, a context that gives you an idea of what's happening when the function is running. And then you can run your code. In this case, I look for a name in the event. If there is a name, I use this name. If there is no name, I use word. And then I say hello Danilo or hello world if there is no name, and I return this as output of the function. So it's a very, very basic example. Oh, interesting. There's been some, the screen decided to change the resolution. Ah, sorry, yeah, it's just me. So we have this very lonely function, but what can we do with this very lonely function? We can actually call this function from almost everywhere. You just need to run an AWS API, so you need to be able to do HTTPS and to sign the API. So you can run it from the JavaScript running in a browser. You can run it from device, mobile apps. You can even expose this to other services. And you need to use the AWS invoke API to run this function. This function should be designed to be stateless, because every time you call a function, it can run on a different server. So you can keep a state in memory, even on the file system. There's a small /tmp that you can use, but it can be used as a cache, but you can't be sure that the next invocation will find the same content there. So normally you need to keep your state outside of the function, and you would use a database for your structured content, or a file repository where you want to store anything that is not structured, like pictures. And most of the people is using tools like DynamoDB or S3 for the files. What is interesting, and this is where things start to get interesting from my perspective, is that these repositories, such as DynamoDB or S3, can trigger another function, can be the trigger that starts some different business logic. And then if we start to look at this with a classical three-tier architecture, we have our client presentation code here. We have our business logic. It's built with different functions. We have a data persistence layer, but there are these rows that goes in both directions, because data persistence layer, the database, the file repository, can trigger logic. And for example, in the book, what I do, I build a very simple media sharing application, a sort of poor man's Instagram, where you can upload your picture with some metadata, like this is a private picture, this is a public picture, and then people can go and see the public pictures or their own private pictures. And what I do, I allow to do this because I can trigger events. When you upload a feature, you can trigger a function that extracts the metadata. This metadata can be stored in the database, and then when you store some metadata of a picture in the database, this triggers another function that pre-computes an index of what a user can see. And pre-computing things is very efficient. When you go to Facebook or Twitter and you go to your own home page, normally there's no database access. They have everything pre-computed for your own page. They only start to use the database when you start to scroll down and go into something that is not very common for people to see. And this can be simplified a little bit like this. So I have a client application, can be a mobile app, a browser, or whatever. This is invoking using the AWS API a function that can write on repositories, and the repository can trigger other functions. Actually, the client, as we saw with Goico, can also go straight to the repositories. It can write on S3, it can write on DynamoDB. There's lots of security measures that you can put on top of these direct calls from the client. And so you can build a logic that completely bypasses functions and only executes functions as triggers. And actually, in my example of the media application, you upload a picture on S3. With S3, you can bring your own metadata, and then this triggers all the functions that process the information, like indexing the metadata, pre-computing the index. Everything is triggered. The only action that you need to do from the client is doing the upload to S3. And it's much more efficient and cheap, because you don't need to run a function for the duration of the upload.
So the authentication.
Yes. But that's something that you want to run on the client. Normally, I put this client application here because I think when you build a web application, you should use the same approach of a mobile app. So everything that can run on the client, you should run it on the client. It can be a browser, it can be a mobile app. And normally there are, in my perspective, 3 reasons why you want to run code outside of the client. One is security, because you can trust the client. So if this is a bank application, you can't have a function to add money to your bank account. It must be something in the backend that validates the transaction. A second reason is because you want to share code with other clients. So if I'm running something on my client, I have my picture, I want to share it with Goico, I need a way to share it. Actually, this kind of sharing can avoid a backend and run on a pure peer-to-peer architecture, but this is a sort of an exception. So this is the second reason. The third reason is because you want to go beyond the limits of your client. So you need more memory, more computational power, something that can't run here. So maybe I want to trigger an algorithm that is processing an image and it's too complex to run on my mobile phone. Then this is a third reason why you need to implement a backend. Everything else should run here because you don't need to have, we have computers in our pockets that are more powerful than what we use to send people to the moon. So I think we can do a better usage of that. Normally, you don't want to still be stuck with AWS API for lots of reasons, because maybe the client application is developed by someone that is a different team, it's not the backend team. So you want to introduce an API gateway that you can use to model your own APIs, maybe using a REST model, for example, and the API gateway can be the interface that can map access to your functions or even to AWS services, because the Amazon API gateway, for example, you can use it to map an API call to S3 with all the limits of the API gateway, because the API gateway, for example, has a timeout that S3 does, that is much smaller than what is using S3. But in this way, you can decouple the client from the backend implementation. And the API gateway actually here is sort of a generic context, because it can be the Amazon API gateway, but can be anything that can map one protocol to call AWS services. For example, the IoT gateway that Goigo was mentioning, and we will see an example of that. There is also a different kind of repositories that I prefer to show as a different use case. They are streams, like what you have available with Kinesis streams. So if you need to upload lots of data from the client, then using tools like streams that are not persistent repositories, but allows you to efficiently process lots of data as in a queue, then it's something that you can run straight from the client. And for example, when you process functions from Kinesis, it's much more efficient because you don't need to process one record at a time with a single function invocation, but you can invoke a function every time you have like 100 records or 1,000 records. So it's much more efficient because you don't consume your 1 million of free API calls for 1 million of records. You can process 1,000 records with a single Lambda call. And also, the repositories themselves can publish data streams. If you use DynamoDB, DynamoDB has a function that is called DynamoDB streams, where everything that happens on the database, all the updates, inserts, can be sent to a stream of data that has a syntax very close to a Kinesis stream, and you get an ordered list of events of what is happening on your database that then you can process with functions. So every time there is an update, an insert, you can process this with your own business logic. And I want to stress that this relationship here is what decouples the client implementation from the backend implementation. So it's something that normally can be quite delicate to work on. So one use case is exactly the one that Goigo was mentioning. It's something that I actually talk a lot about. We have lots of customers using AWS IoT without any IoT device, just for the features of the platform. So you can use AWS IoT to invoke Lambda function using MQTT directly or MQTT within WebSockets. And WebSockets is part of HTTP, so you can create a browser that connects, sends information in real time, receives information in real time, and this information can trigger or be published by Lambda functions. So it's a quite of an interesting architecture. It's completely real time, and it's bidirectional. So it's not like the old web where the client is always polling for information on the server. And we also have the Amazon API gateway. And when we released the Amazon API gateway for mapping HTTP calls to Lambda function, we actually created the templates that introduced the templates that Goigo was mentioning. So the idea that, okay, we don't know what the client will, what the developer wants the API gateway to get and send, and what kind of information must be sent from the HTTP request to the Lambda function. So we give complete freedom to the developers that can use templates. And these templates are based on a standard. It's the Apache Velocity templates that are very powerful, and you can use this to map input to output and back. Problem was that Velocity templates are quite complex, and we also noticed that all the customers were doing all the same thing, because at the end, an HTTP request has always the same kind of information. So later, I think it's now more than 1 year, we launched the Proxy Integration with the API gateway. That is the default integration if you enable the trigger from the Lambda function to in the Lambda console to the API gateway. And this is a standard syntax, so you don't need to do anything. If you, on the Lambda console, you just enable the API gateway as a trigger, this is what you get as a default integration, and you can even avoid to go on the API gateway console at all. So from the request will be mapped into this JSON format, so you get the resource path, the HTTP method used for the call, it's a get, it's a post, the query string parameters, the path parameters, and so on, the whole body. The API gateway supports binary content. Lambda doesn't support binary content because it's expecting JSON. So if it's a binary, we will use a base 64 encoding, and this flag will tell you that the body is actually a binary that you can decode. And then the response back from the Lambda function can use this very standard syntax. It just needs to give the status code. So it's at 200 OK, at 304, 404. You can optionally customize the headers, and then you can send the body back of your response. So if the Lambda function is returning this very simple structure, this can be mapped back to the client doing the API, to the consumer of the API. So this is a standard integration, and my sensation is that not a lot of people is using it, and it's very much easier than default templates. And there's the code to change the previous API to have the previous function to transform the function in an API. So here you can see this is exactly the same code as before. So I'm zooming, so I should remember to zoom back. And it's exactly the same code as before, a little bit more boilerplate, because there's, like, I look in the event in the query string parameters. If it's not null and undefined, I look for a name and I take the name. In this case, I also allow people to customize the HTTP status, so if you want to return at 200 OK or something different, and then I build the answer, the response, as I said, and I return it back. So this is an example of how to transform a basic function in an API with no configuration on API gateway. Everything is managed by the default integration and the code. So normally at this point, a lot of people say, OK, I like the approach, I like the idea of using this function, but do I need to rebuild everything? Luckily not. There's a lot of frameworks, some developed by us, some from the community, that allows you to use standard syntax and map this syntax to the API gateway and Lambda function. For example, this is a framework that is developed by AWS. You can take any Node.js Express application, and almost without changing code, there's like a couple of lines of code, you can embed this application and run them in the API gateway and Lambda. Of course, probably they will need to be a little bit adjusted to use all the features that we have, but you can still keep your default code and run it in a Lambda function. And there are similar tools for other frameworks. So this is for Java containers, and there are others that you can use for other frameworks. Another question that I strangely get often is, how can I go beyond the timeout? So we increased the timeout in the past. But even if you have 5 minutes, you can do a lot of things. And this is an example of what I did. I was working with the product manager of Amazon Recognition. Amazon Recognition is a service of ours where you can analyze a picture, find what's inside a picture, the face, the emotion of the people. And we said, can we extend this easily for people to process a movie, like lots of frames? So in this case, this function was getting in input a list of pictures, and a list of pictures couldn't be processed in 5 minutes. You need more time. So what I did is I have a process list function that gets a list of things to do. And I take the first picture, the first thing that I need to do. I process this first thing. Then if the length is 0, so I process everything, there's nothing left to do, I finish. If there's something else to do, I use the context. You remember, the context is this second information that the Lambda function gets that tells what's happening in the execution environment of the function. The context here is telling me how much milliseconds are left before the timeout. So I know that to process a picture, usually you need less than 1 second. So if I can set a threshold, maybe 3 seconds, if I have more than 3 seconds left, then I continue to process the next element. I'm using recursion here, but you don't need recursion, so I process the next element. If there's no time left, I invoke the same function asynchronously with the remaining things to do. So this invocation is asynchronous. So what happens is that the first function terminates, and the second function will start again with the remaining list of things to do. So maybe I have 100 things to do, 100 pictures or whatever, and then I have 90 left. I call another function that is started asynchronously. And if you think about pricing, as we were doing before, if you do things serially or in parallel, the cost will be exactly the same. So nothing blocks you to say, okay, I want to start lots of things in parallel, and then I can process with lots of Lambda functions in parallel all my pictures and get the result in a few seconds. Actually, we increase this limit. There is a soft limit for all accounts. Now you can run up to 1,000 Lambda functions in parallel in every region. And we are happy to increase this limit if you need to do more. And there's a colleague of mine, he's based in San Francisco. He was helping a startup, and he built, it's now in open source, a complete MapReduce framework based on Lambda function, where you get your input data, you store it on S3, and then Lambda functions are started, we split the data, process the data, reconcile the result, and give you the final result. Everything is serverless, and you can run in parallel as much as you want. And what about larger applications? We will talk, especially the deployment of larger applications. So this, I want to introduce to Goiko. We have SAM. SAM is the family name of the serverless application model. And you can notice that Tim Wagner, our director of serverless technologies, such as for Lambda, and he really likes squirrels. He really likes them. And the idea is that CloudFormation itself was not designed for serverless, and to do a serverless deployment, it requires lots of information. The template gets very long very easily. So we created a standard syntax where you can describe all the features that you need, all the APIs, the event sources, the data stores, such as S3 or DynamoDB. It's quite abstract from the actual technologies, so you don't find like Lambda or S3 in the naming of the application used by SAM. You will see functions or files or database. It's designed to be really an open standard. In fact, we released the specification under the Apache 2 license so that everybody in the community can use the same syntax so that nobody needs to reinvent the wheel, and we have a very easy and portable way to describe a serverless architecture. And now with 2 commands on CloudFormation, you added 2 commands to the command line tool to package an application and then to deploy the application. And the deployment is using CloudFormation underneath, so the deployment can manage upgrades. So we'll do a difference and see if there is an upgrade or a new architecture that must be deployed. So this is the website where you get more information on GitHub, on SAM. And with SAM, you can easily build, for example, continuous integration and continuous deployment for a serverless application. Because you have your code on a Git repository, such as GitHub or code commit, or even as files on Amazon S3. And when you do the commit, you can trigger a build. And you can do that serverlessly using code build. By the way, code build has another free tier. The first 100 minutes of building every month is for free for older and newer account, so you can start using without any cost. Code build can build your code, and then can eventually also run automatic tests. This is an optional step, but it's what I would suggest to do. And then can give this information as output at CloudFormation. Since one of the files here will be the SAM template describing the serverless architecture, CloudFormation can deploy or apply a change to the production environment. Everything is serverless, and you need to wire a few building blocks here, because you need to use code pipeline to design the whole pipeline, SAM, code build. So we started to think, okay, it's good, it's interesting, but still you need to invest a lot of time. That's why we released 3 weeks ago, I think, CodeStar. So CodeStar is a free tool that you can use. There is no cost in using CodeStar. You only pay for the resources that it's using. And with CodeStar, you can create your own project. You can also create a team of developers with their own credentials. You choose a starting application, like in this case, I want to create a Node.js web application using Lambda, and we will create everything for you. So the development pipeline, the source repository, the starting code, all the configuration, all the best practice applied for you. I'm not entering into detail, but also code pipeline, code commit, they are designed to have a nice free tier. So if you start to do that, the first like 5 projects every month doesn't have any cost from all these tools. It's just if you start to use it really at scale that you will see some small cost from these other tools. And I'd like to show you a very quick demo on this. So this is the AWS console. I select here CodeStar. It's in the developer tools section. And you can create a new project. Here you can choose what kind of project you want to build. So I was showing a lot of Node.js. So I hope there's maybe a few Python developers here. So I select Python. And then I can choose I want to build maybe a web service or a web application or an Alexa skill. Let's do a web service. And I have now 3 options. I can use EC2. Beanstalk, or I can build something serverless using Lambda. I choose Lambda. I can give the project a name, so AWS user group UK, create project. And now it will take probably a few minutes to set everything up. And I can connect this also with my development environment. We support Visual Studio, Eclipse, or command line tools, so you have just a Git repository. So this takes a few minutes. That's why I created another project that I called Serverless WS, and this is already up and running. By the way, we also have an agreement with Atlassian, so you can also use Jira without any cost to manage the issues of a project if you create the project using CodeStar. So this is a special agreement that we have with them. You go and configure issue tracking, and you can start Jira without any cost, manage Jira. You can create your team. And this is an example of a serverless application. You get the application endpoint here. I can click here, and I can see the endpoint. Hello London is another Hello World style application. And here you have the information on the commit history on the project. You have the invocation of the project. I'm unfortunately the only user of my own application. And you can also connect these two tools like I did before. So this is up and running. So if I click here, I get the git clone command. I can just copy this command here, go on the command line here, and I can just clone the repository, and I get an error. Perfect. This is not the kind of, probably my credential expired or something, because I deleted everything just before. So AWS, let's see if the command line interface works. So I should have, OK, perfect. The demo is not working. And I can describe the demo by voice because I don't want to do debugging now. I don't know what I did. But the idea is that you can clone the repository, and then you can just push your changes, and the push will automatically, when it works, go in production. So this was the technical part of the presentation. The final part, I want to spend a few words on the value for the developer in the event-driven model. So I try to describe how you can use this function and trigger business logic from the front end, from the back end. But how can you really use this in an event-driven way? So normally we are used to use event-driven architecture in the front end. So it's probably tens of years that we design event-driven application in the front end. So you create like a web interface or a graphical interface, and then you can link logic to something that happens here. So like if I type a name, I can check that the name syntax is correct, the email syntax is correct. When I click submit, I can send the signal to the backend to create a new user. Normally, this is implemented in most programming languages using the observers pattern. So you have something that is part of your application that is observing targets, like the part of your graphical user interface, and if something happens on the target, can trigger actions, that is like creating a new user. The idea here is to do the same in the cloud backend. So the platform itself is the observer. You have lots of services like S3 buckets, DynamoDB tables, Kinesis Stream, and you can trigger an action if something happens on these services. So if I upload a file, I generate the thumbnail for the file. If I change something in my DynamoDB table, I can keep another database in sync. Or if there's data flowing through the Kinesis stream, I can process the streaming data in almost real time. The problem is that this requires a complete change of perspective, because we are moving from the front end to the back end. So if you see this as maybe a back-end developer, what you see on this slide? A function? Yeah. A function. So if you come from this was not prepared. From procedural programming, this is a function. If you come from reactive programming, probably you think this is data binding. So I'm binding the value of the area with two different variables, the length and the width. Data binding means that every time I change this, automatically the area is updated. So it's a different perspective. It's not that I have to compute this every time, but I'm reacting to a change and updating all the depending values. And this is very common in the front end world. The idea is to change perspective, take a different point of view, and use the same approach, the same reactive approach when we design the backend of an application. But it requires a complete change of perspective. For example, if I have two functions, or can be also two services, and one function is triggering another function, like I create a user with service A, and then if I create a user, I send an email to the user to verify the email. So service B is the service sending the verification email. Normally, I think like that A is the trigger for B. But my suggestion is try to think in cause and effects, because our brain, with millions of years of evolution, is very used to think in cause and effects. We look for cause and effects everywhere, even if there is no cause and no effect. But in programming, it can help us keep everything in our mind. That's why microservices are useful, because if you start to do something too much complex, then your mind is not capable of thinking about everything that happens in a single application. Working with smaller components is much better. So think, OK, A is the cause of B. If I create a user, this is causing an email to be sent. And then on and on. So what is causing service E and service F? What is the cause, not the trigger, is service C. So in this way, you have a cause-effect chain that our brain can follow when we develop the application. And you can also have cyclic links. So service E can trigger back service B. And you can think this as an acknowledgement. For example, if you have a chain of events, so I create a user, I send an email, the email is clicked by the user, I receive the click, and the click is sending back to the first service that something has happened, the user is verified, the email is accepted. So this chain of events can also implement acknowledgement. And if you start to think in this way, each of the functions, each of the small building blocks of your application will have a small local visibility. So you may have maybe hundreds of functions, but when you create a function, you only need to know what I get in input, what I need to do inside my service, and what are my output, what I'm causing, what are my triggering. And everything else is something that I don't need to know. So if I start to have a big application, I can focus on every component, what I receive, what I need to do, and what I need to tell. And this helps me keep everything under control, even when I start to scale the complexity of my application. Because instead of having a centralized workflow, like in big monolithic application, where all the logic is in some central place, when you have the logic centralized, when you add a new feature, there is the risk that it's going to conflict with something that you developed 2 years ago and completely forgot, or maybe someone else developed. If you have a distributed data flow, so the logic is distributed and the data flowing through different services is triggering some small piece of business logic, this is much, much easier to coordinate. And this is actually an endless confrontation for software developers. It's better to do choreography or orchestration. My point of view here is choreography. So it's like in a ballet where everybody knows what they need to do, but very few people need to understand the whole ballet. And this is the same here. You are still, so most of the things that you do with functions is still similar to microservices. So there are all the, not all, but some of the pitfalls of distributed systems. So sometimes when I talk with developers, they think, okay, I use Lambda, so everything is magic, everything works. You still need to think that you are running this logic, this code on a distributed architecture. For example, you have to think of what you need to do with the database. Because if you start to share a database across multiple functions, across multiple services, you are tying all this piece of code together. So it's not distributed anymore. If you want to release an update to one function and you need to change the data model, maybe all the other functions are impacted by this. And this is strictly against microservices, where you can independently deploy every small components. And I like these architectural diagrams of two microservices sharing their own relational database. And another point of view that I love is coming from Jonas Bonner. He's the inventor of Akka. He was talking like when you start to get smaller, from the monolith, you have services, microservices, maybe functions. You start to get your application distributed in time and space. It's distributed in space because it's distributed on lots of servers that you don't control, and they can move from one server to another. And it's distributed in time because you have concurrency and latency, and you don't know how much time one service will get to execute or the order of the operations. You start to lose control on the order. That's why you need to think differently. So we need to move from the old ACID compliant world of big monolithic application where everything is atomic, consistent, isolated, and durable, to something different, where everything can be associative, commutative, distributed, and most importantly, idempotent. So you don't know the order when you have a distributed architecture of how things will propagate, how things will be executed. So the best way to create a resilient application is to think that the order of the operation is often something that you don't control. And it's something that we do a lot in Amazon. So lots of updates that we do, they are using eventual consistency, not strong consistency. And with this approach, I'm coming back to the example that I did a few slides before, you can even replace distributed transactions, that is one of the nightmares of distributed architecture, with eventual consistency. Because as I said before, you have a chain of events, and then the last event will report back and tell you that the transaction that maybe is involving multiple components has completed. And you can even change this to have like one service is getting the writes, the requests, the commands, and another service is reporting the status of the operation. This is a very standard pattern in distributed architecture that it's very easy to build with small components. So the idea is replacing distributed transaction with eventual consistency based on idempotent workflows. On the good side is of this approach is the fact that you can scale a prototype to production very easily, like we were talking before. Everything that you build as a prototype, you can very easily scale. You need to think about a database probably, but you can scale to production and grow. Here, for scaling, I suggest you to follow these guidelines. So this is the Reactive Manifesto. There's lots of information online. But the idea is that if you want to build a reactive distributed application, you should think that the application should always be elastic. And this is something that serverless building blocks will do for you. They are easy. They can scale automatically or very easily. Responsive, you should get an answer within a certain time frame. So Lambda can be very fast. Resilient, you should always get an answer, even if it is an error, because in a distributed world, nothing is worse than getting something pending because everything else is waiting for an answer. So it's much better to fail fast and get an answer than to be pending an answer. The only part that is completely not covered by the building blocks and where you should focus your attention is the message-driven part. That means that everything that every information that you exchange should be exchanged asynchronously as messages. This is something that is not part of the platform, but if you start to create a distributed architecture where functions call other components synchronously, that call all other components synchronously, you are not creating microservices, you're creating a distributed monolith where everything is even more fragile than normal. So think of how you exchange information and try to push everything asynchronously if possible. And just for the final words, I want to give you an idea of where we are going with Lambda and where we are thinking to have Lambda function not only running within our own data centers, like normally, but also everywhere. So we have this project. It's called AWS Greengrass. It's currently in preview, where we give you some piece of code that you can download, and you can create a Greengrass core node that can act as a gateway for the AWS IoT platform and can also run Lambda function locally. And Greengrass core nodes can run on Intel processor or ARM processors, such as Raspberry Pis. The minimum requirement for a Greengrass core node is 128 megabytes, so you can run it everywhere. And you can run your Lambda functions outside of our data centers. Currently, we use this in the Snowball Edge. It's our device full of storage, 100 terabytes of storage. Normally, we give you this device. You can ask for this device using the console. You can copy your data and ship it back to AWS to import data very quickly, or use it back to export data from AWS to on-premises if you want. But now you can also run Lambda functions. So we have customers that can bring this in the middle of the ocean, collect data from thousands of sensors, pre-process the data in the middle of the ocean, and then when they reach a port, they can quickly upload the pre-processed data and then ship back the device with all the raw data that they can process again with more time on AWS. And if you want to scale, you can use more than this or even the Snowball. You can't order this by mistake on the console, but there are customers doing this. So this is a customer in the digital mapping space. So they have 100 petabytes of maps. They add something like 85 terabytes of mapping data every day, and they are moving to AWS using, this is a picture taken from one of their satellites, this Snowball Edge that is parked in their campus. There's lots of networking, of course. And they were sharing this mapping information. In the past, they were shipping hard drives or tapes. More recently, they were using FTP, and now they want to move all this information on S3 so that they can use S3 to share the images with their customer in a safe and robust way. Last point, we also are now running Lambda function on our content delivery network on Amazon Cloudfront. So with Cloudfront, we have point of presence that are distributed more fine-grainedly than our regions. And this point of presence, they can act as cache, and they can also run now some Lambda function as logic. And you can use this, for example, to do A/B testing. So when you are very close to your customer, you can get the information from the HTTP request that comes from maybe your mobile app and take some decision to serve one version of the content or another. We have, for example, one customer, one partner of ours. Every screen has a different, on any device, has a different color profile. So an iPhone is rendering color different than maybe an Android phone, and it's different than a normal screen. So what they do, they can intercept the kind of device, and then they can serve a different version of a picture that is tailored to the color space of the device where you are going to see this picture. So, of course, this is maybe not important for some use cases, but if you want to have a very good rendering of colors, this is an interesting use case. And just final remark, as we saw, you can use all these building blocks together. So my great suggestion usually is to people coming to cloud computing or using cloud computing, don't think of servers, don't think that you're renting storage or renting virtual machines, but use services to build your application so that they can scale and be much easier to use. Thank you.
Oh, wow, that was mind-blowing. Yes, questions if you want to win
At least one question.
Oh, here we go.
Where you've got Lambda functions firing off, triggering Lambda functions, how do you stop the equivalent of a Stack Overflow, like a repetitive, recursive function calling a function just endlessly?
So you can make a mistake and have a function calling a function recursively. That's why we have this soft limit. So we don't want you to run too many functions. and there is this, and you can monitor that. So we don't do any specific check because it's something that you may want to do. It's difficult for us to do that, but we have a soft limit. That it used to be 100 concurrent executions. We had understood that it was not enough, so now it's 1,000 functions. So the biggest mistake that you can do is to run 1,000 functions in parallel, and then they get throttled, so you can't run more than 1,000. We also monitor our account, so if you see something strange, sometimes we are proactive with our customers.
With the snowball edges, that's where the execution environment is, but things that are disconnected, where's the persistence layer? What's a persistence layer that's available to me?
So in that case, you have the internal storage of the snowball edge. So it's 100 terabytes distributed to in multiple hard drives. So it's not fault resistant, it's not highly resistant, but you can store the data on multiple hard drives. It's something that we do automatically. So it's not highly available, but it's something that you can use if you want to start processing data as soon as possible. The worst case scenario is that it stops working, but you don't lose the data unless you destroy the device because it's replicated on multiple hard drives.
What APIs are presented behind it? Presented as a...
So you have S3 APIs. So you have the S3 APIs, you need to change the endpoint of the S3 APIs to use the local endpoint on the device.
Great. Any other questions?
When you were talking about having the Lambdas running in the CDN and it being used for A/B testing, is this likely to be abstracted out for an Amazon product like A/B testing?
Of course, I can talk about roadmap, but the idea is that you can very easily build your own A/B testing. So there are lots of customers of ours, like Etsy, for example, that they build very simple libraries to do that. The problem with A/B testing is that normally you don't want to just do random distribution of content. You want to create a population of users that receives a different version of content. So you need to track the users so that you, for example, you create a 10% of users where you give a new feature, and then you want to track these users if this new feature is helping them using your platform better. So this is not very easy to do with DNS or stuff like that. With this approach, you can, for example, have a header that gives you something unique of a user, and then use this to recognize that this is a user that needs to see the B version of a content instead of the A version. But as far as we are going to go, it depends on what our customers are asking.
Hi. Sometimes we have situations where we have demand spikes that occur at predetermined times. You know, we know at 6 o'clock there's going to be a big spike, there's a lot. I've seen a lot of people who approaching this with pre-warming. You know, so you know 5 minutes before you start to ping your Lambda functions to warm up the environments. Are there any? It sounds like a really complicated thing to have to worry about. Are there any plans to perhaps provide some API call that allows customers to just do that? Just say, I'm expecting a big influx of Lambda demand coming in 5 minutes, and get the environments running to avoid that latency when they actually get hit.
So for now, we are working, and we already reduced the cold start. So the idea is when you start when you invoke a Lambda function or some trigger invokes a Lambda function, the first time we create a container for running this code, it will be a little bit slower. It depends on the size of the function, how much libraries you bring. If it's a JVM with Java, if it's not JS, Java is a little bit slower. So currently we are working not on specific edge cases, but we are working on making this faster for everybody. And already now we are seeing that the time is much better. In production, usually you don't have a big of an issue. What I suggest in this case when I talk with customers is keep your function smaller. So especially in the Java world, what I notice is that there are developers coming from Java Enterprise that maybe add 10 megabytes just for logging, because they use this logging library for years. So this is a sort of a different approach. So keep your function smaller. If you go in this way, in Node.js and Python, you can go with much less than 1 second. So you can do in the few hundreds of milliseconds for a new user that is added. And since we optimize everything, this will happen not very much. So we have statistics that normally we use when we are engaged with customer to tell them like the 99 percentile of answering time for their function, how that works, and we give suggestions how to optimize that. But this is something we are really working on now.
You can actually use that CloudWatch alarms as well.
Yeah. No, you can. If the problem is just that to keep them warm, you can use CloudWatch events. The problem is with scaling, you need to fake the calls before. It's not something that we would suggest.
I guess just a follow-up to that. So if we have a very peaky load, for example, of, let's say, 50,000 clients hitting a function within a matter of minutes, is that, would you say, still a suitable use case?
So for us, it's not a problem. We can deploy as much infrastructure as you need. You will get a few of those calls. I say a few because it's difficult to say how much, but it's something that is a very small number, that instead of answering maybe in a single-digit milliseconds, will take a few hundred milliseconds. Or if they're with Java and everything like approaching the 50 megabyte, that is the maximum size for a function, maybe they can take 1, 2 seconds, sometimes 3 seconds to start. So if this is acceptable for your use case, it's okay. If not, normally we engage with solution architect and we can see how we can help.
Okay, so I assume that's kind of a soft limit when you mentioned earlier that there's like 1,000 functions that can be...
No, the soft limit is if you go beyond like the 1,000 concurrent invocations, you get throttled. And throttled means that you get an HTTP error that is throttling, is part of the HTTP specification, and you need to re-invoke the function if you want. And this is something that you can monitor, but if you know that you can get, I don't know, 20,000 concurrent requests, you just need to ask us, we can increase this soft limit. The problem is that some of these requests will need the provisioning of a new container because we need more power, and those will be a little bit slower, and it really depends on the use case. If you start to think asynchronously, like you have a thin real-time web layer, and then all the processing in the backend is asynchronous, maybe with eventual consistency, then this is a problem that disappears by itself.
Okay, one final question.
How does Lambda work behind the scene?
So I think that what we said is that we use Linux containers, and you shouldn't assume anything else. That's my suggestion to you. So we use the Linux containers, and we run on Amazon Linux. You can even get the information of the AMI that we use, so that you can download and run your own code on the same AMI that we use with Lambda. All the magic is in managing the very fast scaling, all the distribution, the concurrency, and the release, the robustness of the platform.
Excellent. So, who's going to win the book?
It's very tough. I think we have like one question because he was pointing.
Oh, okay. One final question. Here we go.
Thanks. Hi, thank you very much. Very nice presentation. I was wondering, where do you think the technology currently is going towards? Do you think how would it potentially change what we're currently doing anyway?
So I'm changing you mean AWS Lambda serverless? Yes. Oh well, on one side, I think when I first saw Lambda, when you see serverless, I think this is giving us an idea of where software development is going. This is my impression. So, and because the big value here is that you don't get just the classical abstraction of platforms where you lose contact with what's happening below. Because with Lambda, you can bring your own binary, you can still call the operating system. So you get simplification without getting the abstraction that disconnects you with the technology. And then usually when I get asked for what happens in the future, I don't know, but I know that lots of things will not change. So people will ask for the functions to run very fast. People will ask for events to be more distributed on different services. So we are focusing on what we know is not going to change, and let's see.
Okay, so the winner of the book is?
The winner of the book, I think there was the question on the cold start, so that one wins the book.
Okay, come on stage and collect it. Thank you. Cool. Oh, should we just hand it over to him? Okay, food is downstairs. We've got one final prize. Thank you so much. Brilliant. Well done. One final prize. Thank you. Round of applause for Danilo. It was fantastic talk. And then the final prize for the evening is an Amazon Echo. Okay, here we go. You want to hold that? Go for it. Pick one. Who's that? Emra. Oh, Emra.
Kivanch. Is that you?
Yes. Congratulations. Well done. Thank you. And thank you so much for coming. I hope you enjoyed the evening. There's some fantastic food downstairs and drink and networking, yeah? So enjoy the rest of the evening and see you in a couple of months. Thank you. Bye-bye.